Question 4. So it's s of x equal g of f of x. So actually f of x equals ln and then cosine x, right? All right. So let's have look the domain. Let's have a look at the domain for cosine x. Right? But here it says the domain is limit to 0 to 2 pi. So let's have a look the input, okay, of cosine x. When x is 0, cosine x equals 1. When x equals pi over 2, cosine x equals 0. When x equals pi, that would be negative 1. And then when x is 3 pi over 2, then it becomes 0 again. And back to 2 pi, it becomes 1. Right? This is the input of g of x. F of x, sorry. F of x. And this is the output of f of x. But the output of f of x become the input of g of x. So you have to think about what happens when you plug in 1 to ln. So ln1. Does that make sense? Yes, we can find the value of that. And then can we plug in this? How about ln0? No. Alright? How about from 0 to negative 1? Any negative value I plug in here is undefined. So you have to take out the domain from here to here. Do you know what I mean? I mean when x between 0 and pi over 2. Okay, not including pi over 2. When x is less than pi over 2, but greater than or equal to 0, your cosine x is positive number. It's a positive number. So that is okay because you can put a positive number, any positive number here, that's okay. However, when your x become pi over 2, cosine x becomes 0. And you cannot put 0 here. That make it undefined. Right. And then also any negative value. So here, all this part, you should take out from domain. So the domain actually equals 0 from 0, including 0 to pi over 2, but not including pi over 2. And then union. This number cannot be because when x equals 270 degrees, cosine x equals 0. We cannot accept ln 0 as well, right? So, but after that value, any positive number is okay. So union, not including 3 pi over 2 to 2 pi, that we can accept that. 2 pi is okay. 2 pi is 1. ln 1, that equals 0. That's okay. All right. And then, so this is the domain. This is the answer for A. How about the range for S of x? Okay. So, you must have think about the graph of ln x. ln x is like this. Well, you'll go through a point we call 1, 0 because ln 1 equals 0. When x equals 1, y equals 0. Okay, so that we will go through that point. Okay, so when your cosine x equals 1, then ln 1 equals 0. Okay, and then from 1 to 0, your cosine x actually is decreasing. Okay, from 1 to 0. That means we have to plug in a number from 1 and slowly decrease to 0. Okay, so you see this graph is when your x move from 1 to 0, the value of y keep decreasing to infinity. All right, so this part will be your range, okay, of the result. So I would say start from negative infinity to 1, including 1, because it's in your range. Okay, this one is difficult. Okay, you have to think about the graph. Think about from your input. Okay, by input, let me back to here. Okay, your input is here. Okay, cosine x is between 1 and -1. However, you cannot plug in any number, any negative number and 0. So actually your input is limit from 0 to 1. Okay, so your graph is only here. So your value of y is from to 0. Oh, yeah, it's to 0. Okay, sorry. This is to 0. Okay. So your value of y can be from negative infinity until 0, but cannot go over x-axis. Okay, that's your range for s of x. Found the 0 of s of x. So let me write again. S of x equals ln cosine x. So when this will become 0, that's how to found the 0, right? When this equals 0, your cosine x equal 1. Why? Because that actually is log base e. And this means e to the power 0 equal cosine x, right? So e to the power 0 is 1. So that means cosine x equal 1. In our domain, that means from 0 to 2 pi, when cosine x equal 1, when x equals 0 or 2 pi. So the answer is 0 or 2 pi. Okay. This part actually is more like an algebra question, and then it's not really a calculus question, so we take it out from the exam. So you got free point here. So question 4, even you don't know how to do it, that's fine. Okay. But yeah. All right, question 5. So first you multiply 2 plus root x over 2 plus root x. So it becomes the limit x approaching negative from negative side. That is a plus b times a minus b. A squared minus b squared. So 4 minus root x squared is minus x. Okay. And the bottom, don't expand this. Just leave it in fraction. So this is 4 minus x, a half. Square root is raised to a half. Okay. And then times 2 plus root x. Okay. This and this are the same. One is 1, the other is a half. So you can use the top minus the bottom. So that becomes 4 minus x, a half. So kind of cross out. So 2 plus root x. And then you can directly plug in x equals 4. Okay. So actually that would be 2 plus root 4. 4 minus 4. Like some people say, hey, this can become 0. If the numerator is 0, that's fine. We just worry about the denominator becomes 0. We don't like to see the denominator become 0. But the numerator becomes 0, that's fine. So that's basically 0 over 4, just 0. That's question 5. And then question 6. So that you can factor into for when x not equal 3, that is x plus 3, x minus 3, and then over x minus 3. So cross out, that's x plus 3. So limit x approach 3. We use the top because approach not equal to, so we use this, not this. Okay, and then you plug in x equals 3, that's 3 plus 3 equals 6. But when x actually equals 3, then you use the button that equals 1. Okay. Determine, alright, this, you must write this. So the limit when x approach 3, of f of x equals not equals the f of 3. This is your reason. You have to write the reason and you got 1 point. So that's discontinuity, and this is removable. Okay, it's not continuous because this not equal to this. You got 1 point, and you tell the reason 1 point, and you say it is not continuous. You got another point, and then removable. You got a third uh, point. Okay, that's question 6. Question 7, basically everyone can got this right. X approach -5. Approach -5 because the left limit not equal to the right limit. If it's from the graph, so you don't have to prove left L RHL not equal to LHL. So you can just write D and E, okay? Because you can see from the graph. Approach -4, that will be 1, right? -5, that's this point, so equal 1. Approach 3, that's 3, and then this 3 is undefined. Okay, so let me repeat again. Does not exist. We use for limit. Undefined. We use the value of f(x). Don't mix up. Does not exist. Use for found the limit, and undefined we use the for this. There's a no value. Cannot find the value for that input. Okay, of a function. Okay, so don't.